So where we got up to in the last video was something like this. And we are actually starting to get there, right? Like our noise is actually happening here. We're starting to get something that looks a little bit like that original sketch that we made, where we've got a line that's going up and down. What we want to do in this video is think about how we can control the amount of movement that's happening here. And I can actually see there's already a problem because you can see that first point, it's always staying the same. So let's think about what's causing that bug where the first point is always staying the same. Actually, maybe that's not a bug. Maybe you want your line to always be fixed at the first and end point. So depending on what you want, perhaps this is a feature and that last line is a bug. So maybe we need to think about how we fix the last point. All right, so let's actually start using these sliders for amplitude and frequency. And amplitude and frequency were two concepts that I talked about in the lecture about sound. Amplitude you can think of as how high up and down some signal is moving. And frequency you can think about as how fast that movement is happening. So here, the amplitude would be how far up and down this line, the segments of this line can move, and the frequency would be how fast they are changing. Let's plug this amplitude and frequency into our sketch and see how we can use them. So firstly, where would you use the amplitude? I think it's actually this number here, 100. By multiplying by 100, that's what's actually making the line go up and down. And if I change that to a number like, say, 1, you'll see that we get a line that really doesn't move very much at all. If you squint, you can kind of see that there's a little flicker. It's moving a tiny little bit, but never more than 1 pixel. If I change it to 10, we get something that moves a little bit more, and so on. So let's actually plug our amplitude in here. Let's say let amp equals slide amp dot value. So we just get the value out of that slider and then put that in here, amp. So when I change my amplitude, you can see that I have control over how much that slider is moving. Let's look at where we declared the slider to see what arguments we used, what we're working with there. So that's up here in the setup. So I declared that amplitude slider with a value going from -100 to +100 with an in-between point of 0. So if I move it all the way to the left, it goes up. If I move it all the way to the right, it goes down. Now what we might want is actually more like a range. So it goes, that the line goes up and down between that central Y position. And to do that, we could say, rather than just multiplying by that amplitude, we could say use the map function. Okay, so I'm going to get that noise value from Y off, and then I'm going to say Y off equals map Y off, which we know always goes from 0 to 1. So that's the first two, the second and third arguments to map. And then the third and fourth arguments is what we want to map it to. So that might be from negative amp to positive amp. So now I'm going to have a line that goes from -100 to 100. So you can see it varies up and down. So I can actually just simplify my slider code here and just have it go from 0 to 100. And I'll still get that up and down movement. The other thing we talked about, just real quick, was that the first point here is fixed and the end point is free. And what we could want this to go either way. We might want to make it so that the first point actually moves as well, or that the end point is always fixed to that x2, y2 position. I'll show you how to do both of those. So in the first case, what we would need to do, the reason for that is that we're calculating px, py here based on x1 and y1, and we're never adding on that first y offset. So to fix that, we could actually just say let I equals 0, and then not initialize these to be the value of x1 and y1, initialize them to be x and y from that first loop, but just not draw the line on the first pass. So we would just say, so if I leave that out and draw it, we'll get a first line that goes from 0, 0, or we get an error. What we just need to say is if I is greater than 0, so if we're past the first loop, then only then we should draw the line. That's because on the first time through the loop, px and py are undefined, so we get an error when we try to use them in our draw function. So here, if I increase it, you can see that that first point is also moving up and down. But I think in the case of what we want to do with our line function is actually fix the last point, so it always draws at x2, y2. So what I'm going to do is go back to this. So the first point is fixed. And let me just make that default value for that amplitude to be 50. And what we want to do is not actually loop all the way to the last one. Let's loop to be less than length. And then after that, at this last point, we can just draw that line from px, py to x2, y2. Just draw the last line in and that'll be fixed. So now I think this is probably what we want. It's fixed at the first and last point. So we can vary the amplitude. Let's now vary the frequency, how fast this is moving. Let's try and make it move a little bit slower. So the way that we do that is by dividing this here, reducing the frequency with which we sample the noise function. So if you think about this, every single pixel that we go across, we're sampling at a different noise position. So if we divide this, we're going to sample close together and we're going to get a smoother noise output. So let's just say let freq for frequency equals slide freq dot value. And this slider goes from 0.001 to 0.1. And it has a default value of 0.01. So it's quite a small number. So we're going to multiply our frame count plus I by this number. And I'm going to just create a little temporary variable for that. I'm going to say let sub x equals frame count plus I. And all of that is going to be multiplied by our frequency. And then I can just use, use my sample point in the noise function. So now we have a line that moves much more slowly. Okay, so if I increase the frequency, it starts to move faster. If I move it all the way down, it's going to move quite slowly. It's actually becoming quite smooth here. And I can make the amplitude greater or less. So now we're actually getting something that's starting to look a bit more like what we were thinking about at first when we were looking at these images of pieces of string. You know, we don't have knots and loops in them, but it's not this crazy waveform that we had before. And we have control over it through these two parameters. So I think this is a really useful technique. Make a little sketch that just tests out how to do this one simple thing, put a couple of sliders on it, and then you can think about, okay, what are the parameters that I need to give to that function that I'm going to create. In the next part, I'm going to take what we've written here and bundle it up into a function so it's easier for us to use. That'll make it possible to draw multiple of these lines going from different points on the screen. And if I get that working, then I'm going to come back and add in the sound element and make this vary according to the amount of amplitude of the sound. And perhaps you can already see where I'm sort of thinking of going there is I'm thinking of connecting the amplitude to the amplitude of the song that's playing.